Welcome to The Explainer. Today, we are pulling back the curtain on what has to be one of the most bizarre, yet completely brilliant mechanical workarounds in transit history. We're diving into an era where rapid urbanization collided head-on with public fear, forcing engineers to get incredibly creative. So get ready, because we're about to unmask the fascinating world of the undercover engine.
Picture this, it's the late 19th century. City streets are booming, chaotic, and completely packed with horse-drawn traffic. These cities desperately needed mass transit to move people around. But there was a massive hurdle. They were facing strict city rules that outright banned terrifying, fire-breathing trains from running through the streets. And honestly, it makes sense. People were terrified of boiler explosions, and horses, which were the primary mode of transport back then, were easily spooked by the hissing, clanking, and billowing smoke of a standard steam locomotive. So, how on earth do you get the raw power of steam into the heart of a city without causing a total panic? Well, the ingenious solution was basically a mechanical Trojan horse. They called it the steam dummy. If you were to look at the Geary Street Park and Ocean Railroad motor, it looks exactly like a standard, harmless wooden passenger streetcar. But hidden completely out of sight inside that wooden body is a full-fledged, fire-breathing steam locomotive. They quite literally built a box around the engine to disguise it. It was the perfect camouflage, fooling both the horses and the skeptical public into thinking it was just another carriage, minus the horse.
Section 1. Rules of the road.
Because you see, just slapping a wooden box over a locomotive definitely wasn't enough to satisfy the authorities. To get these hidden iron horses onto city streets legally, lawmakers mandated some incredibly severe restrictions. Speeds were strictly capped at a meager 16 kilometers per hour and an even slower 12 kilometers per hour over in the UK. But speed was the least of their worries. The law actually stated these machines had to be completely silent, free from any blast or clatter. They had to emit absolutely zero smoke or visible steam. On top of that, all moving machinery, like the rods and pistons, had to be completely covered up to 10 centimeters from the rail level to prevent accidents with pedestrians. And just to ensure the driver always had a clear view without having to physically turn the entire train around, most were mandated to have a driving cab at each end.
Section 2. Engineering noiseless motors.
Now, hiding the wheels behind wooden panels, that was the easy part. But making a boiling, high-pressure steam engine genuinely noiseless and smokeless required some serious engineering magic. Surprisingly enough, the first major fix was incredibly straightforward. To solve the smoke problem, these motors simply burned coke instead of traditional coal. Coke burns much hotter and significantly cleaner, producing virtually no visible smoke. So that checked one major legal box, but it still left the massive, highly visible, and very loud problem of hissing exhaust steam. To tackle that exhaust steam, engineers essentially split into two opposing camps. On one side, we have the condensing method. Builders like Kitson & Company used roof-mounted air-cooled condensers, you can think of it like a giant radiator, to cool the exhaust steam, turn it back into water, and return it to the tank. But on the other side, we have a much wilder approach. William Wilkinson's 1881 method of reheating the steam. Instead of cooling it down, Wilkinson's design routed the exhaust right back into a hot chamber inside the boiler, superheating it. Expanding into that hot chamber minimized the noise of the exhaust blast and made the steam completely invisible as it exited the chimney. No water vapor, no clatter, and most importantly, no terrified horses. All of these brilliant engineering solutions were meticulously standardized into different classes of broad-gauge tramway motors, and we're talking about a massive range of power here. They range from nimble 19,000-pound machines up to absolute beasts weighing 55,000 pounds, packing 14 by 20-inch cylinders. That largest class was capable of hauling an astonishing 800 tons on a level grade, all while creeping silently and completely invisibly through crowded city streets. It's really incredible when you think about it.
Section 3. The Baldwin Locomotive Works.
Once the core technology was perfected, one of the greatest champions of mass-producing these urban marvels was the Baldwin Locomotive Works over in Philadelphia. They innovated heavily to improve ride quality and track navigation on those famously uneven city tracks. A huge part of this was their highly successful double-ender design. Notice the small wheels at the very front and back of the motor. Those are called pony trucks, and they were the absolute secret to navigating tight city corners that would easily derail a standard, rigid locomotive.
There's a quote from the era that really hits the nail on the head regarding why this design was superior. It points out that the truck at each end enabled the motor to traverse short curves with facility and relieve the driving wheels from excessive friction. Basically, because it distributed the weight over a greater wheelbase, it allowed the motor to run incredibly smoothly on tight, uneven curves. And even better, being a true double-ender meant it could run perfectly in either direction without needing to be physically turned around on a turntable at the end of the line. That was a massive, game-changing advantage in dense urban grids.
Section 4. The end of steam trams.
Now, despite their sheer mechanical brilliance and widespread use, literally all over the globe, from Sydney to Paris, the golden age of the steam dummy obviously couldn't last forever. As the 1900s rapidly approached, cities began to modernize, replacing these intricate, heavy steam machines with much cleaner, simpler electric trams and buses. But they didn't just disappear overnight. While major cities phased them out around the turn of the century, these rugged little engines proved so reliable that rural steam tram lines actually held on in places like France, Belgium, and the Netherlands all the way until the 1960s. No way, right?
Section 5. Preserving the iron horses. Thankfully, the legacy of these mechanical marvels and other historic Baldwin locomotives didn't entirely end up in the scrapyard. Today, you can still find perfectly preserved survivors. Just look at the timeline. You've got the 1873 Empire sitting beautifully preserved at the California State Railroad Museum. You can actually go visit a genuine 1888 steam dummy, the Mammoth Cave Railway No. 4, preserved right at Mammoth Cave National Park. And amazingly, the 1928 Walt Disney World Railroad No. 2, the Lily Bell, is still a fully operational narrow-gauge locomotive pulling passengers daily in Florida.
It really makes you think, doesn't it? So the next time you see a sleek, silent light rail vehicle gliding effortlessly down a city street, take a second to consider its DNA. The push for noiseless, zero-emission, hidden urban transit isn't just some 21st century invention. It's actually a century-old quest, pioneered by these brilliant steam engines hiding in plain sight. And it leaves us with one big question. If engineers went to these incredible lengths over 100 years ago, what kind of radical transit disguises are being engineered for our cities right now?